clear today. First, let's prove a lemma. Okay, so this lemma is called Incenter, excenter lemma. So first, we know in this picture, triangle ABC. This is the triangle we have, and the incenter that actually means the circle center of the incircle. So it's point I. The incenter is point I. So, and what's this circle? This circle is the circumcircle. Okay, this is a circumcircle of triangle ABC. So the excenter means the circle center of the X circle, right? So here it's IA. It's IA. Good. Excenter is IA over here. So, when we think about the lemma. Okay, this is a lemma. So what's this? We can draw a circle over here. So the circle center of this blue circle is L. So what's the definition of L? So you see we have an arc over here. It's created by BC. So we also have a chord BC over here. So L is the middle point on this arc. So how do we find it? We can draw the perpendicular bisector from chord BC. So we can have point L. That's how we find out that. Okay, so now what we have? Okay, so if we have point L, now we can create this triangle. This circle. So we have the radius. We can draw it over here, 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 and here. So what we're going to prove is these 4 points, both of them are on this circle. Good. Now how do we prove it? Is that first we're going to prove that point B and I are at the same circle. Wait, so what is the circle? The circle center of the circle is L. Okay, so the next step over here is how do we prove BIC, these 3 points are at the same circle? Okay, so depending on what we say here, we have that first we need to prove another thing is that I and C, they're at the same circle. But this is not enough, because if they're at the same circle, that means the circle center could not be at the point L. And what we're going to do is that we're going to prove that the circle center of when B and I are at the same circle, and when I and C are at the same circle, their circle center is always L. So, of course, then we have, that tells us that I and C, when they are at the same circle, the radius of the circle they're at the same at the distance of it need to be equal I and L. But if it's like this, and maybe C is over here, then the radius is over here, and the radius is over here. So the circle is over here. So that tells us another thing is this radius the place of this radius need to be the same with IL. Okay, so the next step. Depending on this, we know B, I, and C are at the same circle. And at the same region now, IA is also at the same circle. Okay, this is how we prove it. Now let's use algebra to prove it. So first we're going to prove that B and I are in the same circle. Okay, so that means we're going to prove BIL, this triangle, is an isosceles triangle. So we're going to prove it's an isosceles triangle. We can draw here. Good. So now if we have this, next step, the isosceles triangle we're going to prove is triangle BIL is isosceles triangles. Okay. Now what we do? That means we're going to prove BL equals IL. Good. Now what we have? So, okay. Now, first we're going to prove, so first we're going to find angle IBL is equal to a value, another angle. We can express this angle using angle A, angle B, angle C. So now we're going to write it out. And here, it is this angle. Okay, so we can just break this angle to two parts. So which two angle is it? IBC, angle IBC, then plus another angle CBL, then plus angle CBL. Okay, good. Okay, now what's it equal to? The next step, so we plus them together, right? So this angle, because if we draw a line from I to B, this line is the bisector of angle B. So this part actually, it is a half of B. Angle IBC. Angle IBC, right? This is 1/2B, a half of B. But what about this? We can change to a half of A. Why? Because now we focus at this circle. So here it's CBL. So here's triangle CBL. Sorry, here's the angle CBL. So it's this angle. Okay, now what do we think? We can fix point C and point L, then move point B to A. Okay, this angle is the same because we can use the incredible angle theorem. So what we have? Okay, let me write this angle first. IBC. Then what we plus? Angle LAC. LAC. Good. So that means this is equal to 1/2B plus 1/2A, right? The next step. What's the next step? Now, of course, we're going to prove we're going to prove we're going to calculate angle BIL. Okay, so what is this equal to? So we can use the external angle theorem. If we use the external angle theorem, we have something like this. If we have a triangle, then this angle and this angle, when we have another angle. So right here, if we draw a line over here, if we draw the extended chord over here, so this angle is equal to the sum of this angle and this angle. Good, right? Because this angle plus this angle then plus this angle is equal to 180 degrees. So this angle plus this angle is equal to how many? It's equal to 180 degrees minus this angle. So and then if we focus at this angle, then what we have? This angle is equal to 180 degrees minus this angle. So they're equal. So right here, that tells us that angle BIL over here is BIL. This angle. Good. This angle, that tells us, and if we focus at the triangle ABI, this triangle, that tells us that angle BIL is equal to angle ABI plus angle BAI. So this is equal to a half of B plus a half of A. One of 2B plus 1/2A. Good. Now what we have? Okay, so that means we have angle IBL is equal to angle BIL. That means BIL, triangle BIL is an isolated triangle. So, okay, this is an isolated triangle. That tells us BL is equal to IL. That means we prove these two radius are equal, are the same. So that, okay, this means B and I are in the same circle, and the circle center of this circle is L. Okay, next step, we're going to prove I and C, okay? This is what I say, right? A and C are in the same circle, and what's the condition of the circle, blah, 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 blah. Okay, I don't talk about this because I talked about it before, so we have to draw another circle. Okay, Good, so we have this circle. Okay, so if we have this circle, what are we going to do? It actually is using the same reason. If we think about angle ICL, we have, if we think about angle ICL, so, okay, and we calculate this angle. We're going to break it into two guys, angle ICB and angle BCL, right? Okay. So angle ICB is a half of C, and angle BCL we can fix point B and L and move C to A. Okay, a half of A. So a half of C plus a half of A. So then what about angle LIC? So of course we can just think about focus at triangle ACI. So what about this angle? Sorry, we think about this triangle, right? We focus at this triangle, so that means angle LIC is equal to angle IAC plus angle ICA. Good. So that is a half of A plus a half of C. Good? Okay. So we have this. That means angle LIC is equal to angle LCI. That means, okay, that tells us triangle ICL is an isolated triangle, right? So, and then that next step, what we know? We know that IL is equal to CL. So that means, okay, so what does that tell us? That tells us BL equals IL equals CL. Then we're going to prove that BL equals IAL. We can draw some triangle over here. Sorry. Draw a triangle over here. Okay. Now we have triangle BLIA. We're going to prove this triangle is an isolated triangle. So that means that is equal to, that is same with, we're going to prove that angle LBIA is equal to angle LIAB. Right? Okay. So what we have here, if we're going to prove that, we're going to find what is angle LBIA. Okay, so what is angle LBIA? Let's see. Let's focus at IAB, this line. So, and let's check. Because let's think about IA is the excenter of triangle ABC. We're going to draw a picture. So, okay, we're going to draw a picture. Maybe this is the triangle. Okay, extended line. Okay, extended chord. Okay, so now it is these circles. Okay, so this is circle center. We also have some circles over here. There's a circle center. And we also have some circles over here. Just like this. Okay. just something like this. So, okay, now what we have. Let's see, we can think IA is over here. This is an IA, maybe. Okay. What are we gonna do next? We can draw a line from IA to this one over here. Maybe it's just line LA to IA to B. Okay, IA to B. Here's IA to this point. Next step, let's see, because depend on the definition of the X circle, we have 3 radius that are perpendicular to their tangent. So if we draw a radius over here, it's perpendicular, and draw a radius here is also perpendicular. Okay. So it's okay. So like now we can, because we draw a line over here, so then we have this triangle and this triangle. Then if we prove these two triangles are congruent, then that means this angle is equal to this angle. Then that means IA, if we line it, that means we're gonna draw here. IAB is the angle bisector of this whole angle. That means this angle, right? Over here, how do we prove? We can use the ASS postulate. ASS postulate. Okay, so first we know this side is good at this side. Actually, you can say the hypotenuse. Okay, this hypotenuse is your hypotenuse, and this side, yeah, because these two guys are radius, so they're equal also. And 90 degree, 90 degree. So ASS. Okay, we prove it. Good. If we prove it now, we know angle IABC, this is a half of this angle. So if you think about it, we also can use the exterior angle theorem. Now that means angle IABC is a half of angle A plus angle C. That means it is 1 over A plus 1 over 2A plus 1 over 2C. Good. Now let's focus. Now we're gonna calculate is angle IAB. So now we can focus a new triangle, because over here we have a triangle AIAB. This triangle. Okay. So now we already know that angle BAIA and the angle ABIA, these two angles, both of them can be written as, you see something like, it can be written as angle A, angle B, and angle C. Then we use 180 degree to minus their sum, so we can calculate out what? We can calculate out angle AIAB, right? Good. So now, first notice one thing. 180 degree can be written as, we can change it to angle A plus angle B plus angle C. Okay. Angle A plus angle B plus angle C. And minus, 1 over 2A plus, here's a B, plus B, plus 1 over 2A, 1 over 2C, because this angle, right? Okay, 1 over 2A, 1 over 2A. It is A. A, B, 1 over 2C. Okay, here, of course, is equal to 1 over 2C. Good, so this is the answer. Now we know angle angle LIAB is equal to 1 over 2C, and we know angle LBIA is also equal to 1 over 2C. Yeah, okay, I forget. When I'm talking about how to calculate this angle, yeah, first because you have this angle is 1 over 2A plus 1 over 2C. And this angle is 1 over 2A, so that means this angle is 1 over 2C. Okay. That's it. So this is how we prove the incenter, excenter lemma. So the second part of today's lesson is we're going to prove Heron's formula, of course. Okay, let's see. Here, IA is the same meaning, okay? And the L means here is right, here is O. Okay, let me see. Triangle ABC, good. Now, I, same meaning with here, I. So now we can draw a perpendicular from I to BC. So we extend it to this whole circle. So here we have a P. Yeah, here we have a P. Then we have another Q. Then when we draw a perpendicular line from IA to here, and it's R, right? Okay. Now, first we're going to prove this quadrilateral. Here, we have a quadrilateral is IA, Q, P, R. Good. This quadrilateral. We're going to prove this quadrilateral is a rectangle. We're going to prove it's a rectangle. So what's the next step? Okay. Now what we have? First we have angle IA. We can use the incredible angle theorem, right? So if we use the incredible angle theorem, we have angle IA, Q, P. Actually, it's IAQI because these 3 points are on this circle, but it's the same if we move to P. This is equal to 90 degrees. And we know these 2 angles equal to 90 degrees, of course, because when we draw it, it's perpendicular. Good. So these 3 angles, all of them are 90 degrees, so all of these 4 angles, their sum is 360 degrees. So if the sum of these 3 angles, these 3 angles, all of them are 90 degrees. So of course this angle is 90 degrees. Okay, so proved it. So and if we prove it, we have Q, P equal IA, R. Okay, this is what we're gonna actually prove. You're gonna use it later. Good. Now, what's the next step? First, let's see how do we prove IP, okay? IP is actually equal to triangle over A plus B plus C over 2. So what does this triangle mean? It's the area of triangle ABC, okay? Okay, so now we draw a triangle over here. Okay. This is a triangle ABC. Now if you think about, okay. You see, this point is I. Then if we draw IP is actually the radius of the circle, right? So we can draw these 3 lines. It actually is a bisector. So when we draw these 3 lines, we can create 3 triangles. This triangle, this triangle, and this triangle. So these 3 triangles, if we can calculate this triangle, the area of the whole triangle, so this triangle plus this triangle plus this triangle. So all of these triangles, how do we calculate? We use this radius times this, maybe it's A. We use a radius times this is C. Or radius times this is B. Good. Sorry, don't forget the 1 over 2. Okay, so we can factor out the 1 over 2 and the radius. So we factor out the radius. So now it's the radius times A plus B plus C then over 2. Okay, so so this is equal to the triangle. So okay, then what's the next step? Of course, because we're actually gonna find out IP, IP, I mean the radius. So, okay, what's the next step? Is that we're going to move a plus b plus c over 2 to the left side maybe. Or we can say the right side is fine. So, and then that tells us that IP is equal to triangle over ABC over 2. A plus b plus c over 2. Okay, this is the first thing we're going to prove. The next thing we're going to prove, this is the first thing we're going to find. And the second thing we're going to find is IA R. This is equal to, okay, I don't say it first. Let's think. Remember what's IA? It's the X circle, it's the excenter, so. Okay, not so. Then we're gonna solve it. What's IAR? We can draw this triangle. So extended chord. Okay. There's some sort of circle. Well, I don't draw really good. Well, circle center is maybe over here. Well, this is IA. What's next step? It's over here. Here we can draw a perpendicular line over here. So this point, it's R. What's next step? Now you see this is R. Okay. Good. What's next step? We're gonna find what's this. Actually, it's a radius, right? Good. We draw a line over here and draw a line over here. Actually, it's also perpendicular. I don't draw really good, okay? Yeah, some sorts like this. Good. If it's perpendicular over here, we can calculate. We're still going to calculate the triangle's area, okay? But we can draw 2 lines over here. These 2 lines. Good. We can draw 2 lines. We can draw another line from here to here. Okay. And if we're going to calculate out the area of this triangle, that means we can calculate, we use this triangle to plus this triangle, then minus this triangle. Okay, so what is that high? This triangle is high. Okay, extended chord over here. This high is just a radius. Okay, what about this triangle? Its height is over here, and if we times, okay, we times A, we times B. We times B, we times C, and here this triangle is times A. So actually, over here it's the same way. So now remember, it's minus A's part. So it's B plus C minus A over 2. Good. Next step is we're going to prove other 2 guys. These 2 guys are BP and PC. Okay, let's see. BP over here is this guy. Remember, I don't write it. Here's A, here's B, here's C. Remember. Okay, well, first now BP is this. Okay, how do we calculate it? We can use A plus. So first, remember, when we are finding the in circle, sorry, not here. When we are finding the in circle, so when we are finding the in circle, this is equal to this is equal to this is equal to this. Okay. Now, if we have this, when we are calculating BP, first we can use A plus C. So it's this plus this plus this plus this. 2 times this, and then have this and another this. And if you minus a B, so you have minus, and you have cancel out this and this. Okay, now you've left 2 times of this. So what do you have? It's A plus C minus B over 2. Good. And this is similar to when we calculate out this. So A plus B minus C. Okay, I don't say it's the same. A plus B minus C over 2. Okay, so now we have another thing is the circle power theorem. So, circle power theorem is in a circle. We're going to have 4 points. Draw over here, draw over here. So we can draw a line over here, and I'll draw a line over here. So first we're going to prove these 2 triangles are similar. So how do we prove it? Okay, let's see. Now we know because these are 2 straight lines, so these 2 angles are equal. Is it because if it's similar, so we at least we need to prove 2 angles are the same. And now how do we prove this angle is equal to this angle? This angle means this arc. This angle means the same arc. So we have these 2 angles are the same. Now, so we can get these 2 angles are also the same. So these 2 triangles are similar, and we can flag this over here. We set this A, this B, this is C, and this is D. And this is E. So we have AE over A, because we can flag this triangle right here. So AE over DE equal BE, equals CE over BE. So both side times DE and BE, so we have AE times BE equals CE times DE. What's the next step now? Okay, this is the circle power theorem. AE times BE equals CE times DE. How do we use it over here? So, okay. Now here's the point we can use the QP equals IAR. Okay, how do we use it? So first, using the circle power theorem, we have BP, BP times PC equal QP times PI. So the point over here is QP, we don't calculate QP, then we calculate IAR over here. And we've already proved because this quadrilateral is a triangle, that means QP equals IAR. If over here is that, I'm going to change it to IAR times PI. Okay? So BP times PC equals IAR times this. Okay. This times this equal to this times this. So right here, the right side we can both. So we have triangle over this times triangle over this. So both sides times this and this. So the left side we have this times this times this times this, and we have another. So the right side is triangle square. So we need a square root. And another thing we're gonna set something. So it's a half of the parameter. We set it as S, and that's equal to A plus B plus C over 2. Okay, so here we can use it. Let's say example, B plus C plus A over 2, it is S minus A. Because over here, if we change it to S, so B plus C plus A, then we minus a 2A over 2. So if we take it down from the numerator, so it is A. So it's S minus A. So finally, we have the area equal square root S minus A, S minus B, S minus C. So this is the answer. A equals S times S minus A, S minus B, S minus C. So we've proved the Heron formula. Okay, so now we have something to add, is that when you're drawing, if some sorts you're gonna draw the picture when we're proving the Heron's formula in this graph, and when you're drawing this picture more precisely, actually we're gonna prove another thing is that IA and point O and the point I and point A, these 4 points are at the same line, so are lying at the same line. Okay, now let's, because we actually need to prove this in the graph of the incenter excenter lemma, but we actually didn't need to prove this thing when we are proving Heron's formula or incenter excenter lemma. But when you're drawing the picture of Heron's formula much more precisely, then you need to know this. And so, of course, if you're going to know this, you need to prove it. Okay. So, if we're going to prove these 4 points are on the same line, what we need to do is first we're going to prove point A, point I, and point IA are at the same line. Then we're going to prove something else about L, I, and IA. I'll tell you later. So, first let's prove these 3 points are at the same line. So, first let's see some property of IA. If we can draw the extended chord from line AB, and we can draw the extended chord from line AC, then we can draw 2 perpendicular lines from IA to these 2 extended chords. Then these 2 lines. Let's see if we have it. Actually, I can draw a triangle first. I told you it's very easy that. Okay, so okay, so the point maybe is over here. I think it's over here. Yeah, it's over here. So draw a perpendicular line and a perpendicular line. So what's the next step? So these 2 angles are 90 degrees. Maybe I'll draw them around the degree. So let's see. What about I over here? We can draw 2 bisectors. So we have this I. So I. Okay. I'll talk about I later. First, let's see over here. So we can draw a line from IA to A. Okay, first don't draw I. So, and the next step is depending on what we say over here is that if we draw a line IA to A, we create 2 triangles. So first we can set this point K and point J. So that means we create 2 triangles. So the left triangle is triangle AKIA, and the right triangle is AJIA. Good. So then the next step, if we have these 2 triangles, we can prove these 2 triangles they're congruent, so we can use, and then we can use the ASS postulate. Over here is the angle is 90 degrees and 90 degrees. So then angle AKIA and angle AJIA. These 2 angles, both of them is 90 degrees. Good. And we know IAK and IAJ, they are equal because these 2 segment is the radius of the X circle. The radius of the X circle. So they're equal. Then another thing, because we have a super if we draw these two triangles in this picture, there is the hypotenuse of these two triangles are superposition. And right here, they're really superposition and they're the same distance. They have the same distance. Good. So, the hypotenuse is the same. It's equal. So, that means it's ASS. Using this postulate, we can have what? We can have these two triangles are the same. Are congruent. That means angle KAIA is equal to angle JAIA. These two angles are the same. And we know their sum is A. So both of these two angles are 1 over 2A. That means if you draw a line from A to IA, this is the bisector of angle A. So actually, remember what we're going to do when we're drawing I. When we're proving the last thing, is that we also can draw a bisector from A, so we also can touch I. Then we use the same method, and we can draw these two perpendicular lines. And they're the same, and these two triangles are congruent, something like this. Then that tells us if we draw a line from A to I, this is also a bisector of angle A. So AAI and AIA, these two lines, both of them are the bisector of angle A, so that means they're at the same line. They're on a line that is the bisector of angle A. Good. That means we prove point AI and IA are at the same line. And the next step, because we're actually going to prove these 4 points are in the same line, so we need to put L at this line too. Because remember, we've already proved that I, IA, B, and C, these 4 points are at the same circle, and the circle center is L. That means if we draw a line from I to IA, a straight line, and it touch L, that means this line is the diameter of this circle. So how do you prove this? Remember, using the incredible angle theorem, if we have a triangle over here and the angle over here is 90 degrees, that means, just example here is, we're going to prove angle IBIA is equal to 90 degrees. So why is that? Because if we prove this is 90 degrees, that means it's perpendicular. It's tangent. It's perpendicular. That means, using the incredible angle theorem, that of course that tells us I and IA is the diameter. Good. Now what we have? If we have this, that means we're going to prove. Okay, then we can break it to two angles. Angle IBIA is equal to angle IBC plus angle CBIA. Good. So we know angle CBIA is a half of this angle. We can draw an extended line from extended chord from AB, so we're gonna have this angle. So of course, and we know that angle CBIA is equal to 1 over 2A plus 1 over 2C. So what about this angle IBC? Of course, this is 1 over 2B. So that's equal to 1 over 2B plus 1 over 2A plus 1 over 2C. Good. So if we have this, now what's the next step? If we have this, then remember, because we have a triangle ABC, that means angle A plus angle B plus angle C is equal to what? It's equal to 180 degrees. So this And actually, 1 over 2b plus 1 over 2a plus 1 over 2c, of course, it's 1 over 2 times bracket a plus b plus c bracket. So that's 1 over 2 times 180 degree. Then what we have, of course, that it is 90 degree. So this is how we prove that A, I, L, and IA are at the same line. Of course. Then when we're drawing the picture, we know how to draw these 4 points, right? Good. So actually that means we have some properties just like I, O, and I, A, O, and I, and A. These 4 points are the same line. Okay. So this is the last part.